Hello students, how are you all? I hope you're doing fine at home. I am your teacher Neha and today we are going to see a new chapter which is named as Work and Energy. So this lesson is from Physics 7th standard. So children, whenever I say word energy, what do you understand? Yeah, look at the picture and say yes. So it's looking like some internal kind of radiations which are just like coming and closing us, right? So that's what we are going to see today, but not the virtual thing, but we are going to see reality what happens, okay? So let's see what happens here. What this girl is doing now, children? Yes, she is cycling, right? So she is pushing the paddles so that she can move, right? Yes. Same way, whenever you want to talk about energy or work, there is two kinds of thing. One, it will be that you have to apply your physical standards or your physical work, right? So that way, just see here what the sponge box is doing. Yes, he is hammering the nail so that the nail goes down. Same way, in the second picture also you can see that there is a carom board where you are taking the coin and you are just playing so that the coin moves. There also you need an energy, right? Even for hammering you need energy. Just imagine you don't have energy. If you are just putting like this, whether the nail will go inside? No, right? Yes. So that's what here we are talking about is only energy. So these are the common examples which we are going to discuss here, and normally also what are all examples you know, you can use it. So here see children, the girl is singing, right? And the boys are playing football. So even when you are singing, even right now when I am talking, I need energy to talk, right? Just imagine I am very tired, I cannot talk. Then what will happen? Will you hear me? No, right? So for doing each and every work, you need energy. Yes? Yeah. So we have talked about just moving around, playing, hammering, because there are movements. But there are some kind of works where there is no movement of a person, but there will be thinking and a person who is standing here right now. So just tell me whether these two people are doing any work. Let us see the answer in the next slide. So see here children, what does the factors determine what is a work? So children, whenever you are talking about work, that means you need energy. Right? So for doing anything, let it be even holding a pen, speaking, singing, dancing, you need energy. So same way, there is a basic thing where the work is required is, first is displacement. Displacement means when this trolley is moving towards this, there is a distance covered, right? So the first factor which affects the work is displacement or a small distance. Same way, there is one more word. What? Yes. How it is moving? Just like that it's moving. No, right? This person is moving a force. He is giving a force. Only then you can see that there is a change in the position of a substance. So this is why these are the factors which will affect the work. So you can even write it here children. You can write that work is always dependent upon the force which you apply. What it is? Force into the movement. Movement, what word I told you children? Yes, it is displacement. Okay? Yeah. So even in short form, if you need to write what is work and displacement, here you can write that W, which is work, is equal to force into the displacement. This is small s, okay? So capital F, small s is equal to the work which you have done. So these two factors are depending, and these two factors are the main, formula, okay? So just remember this. Now see, we have talked about the displacement. For example, now here see what's happening. The apple is coming down, right? So here, do you see any displacement happening? No, right? So see children, displacement only means when the position is changed from left to right or right to left, not top to bottom, because here what is happening, it is just coming down, there is no movement like this, it is not sideways. So this will be known as a zero work, because just imagine you are taking this, here force is applied, here there is gravitational force, right? Yes. So because of the force the apples are coming down, but there is no much movement to the sides, it is just coming down because of the gravitational force. So here the work done by the apple will be zero, okay. So just keep in mind. So let's come to the factor what I was saying here. I was saying that tell me whether these two people are thinking and he is standing, whether they are doing work or not. Now tell me. Yes, they are not doing work, because here even the sponge worker is thinking, right? He is thinking but he is not moving. So force is applied on the brain but he is not moving, there is no displacement. So thinking is known as no work done, it is just a process, okay. Same way standing, standing means here the child or the person is taking the bag and he is just standing, right. So whether he is doing work? No. Why? Yes, because here displacement, which is movement, is absent, okay children. Yeah, very good. So now let's come, what are the units of work? So let me first write the formula. So the formula of work is, you can write work is equal to force into displacement. Right? Yes. So children, let's find what are the units for this. So work, you don't know what is the unit, yes? So work is a question mark. Now force children is always denoted as Newton. Why it is known as Newton? Because Newton was the first person who said that there is a kind of force attracted towards the earth. So if there is a gravitational force of coming apple down, then it is a force, that is why unit is given as Newton. Force unit is Newton, you can write it as capital N. After that, displacement. Displacement is what? Yes, displacement is movement. So movement SI unit which we have studied is in meters. You can calculate in meters, right? Yes. So displacement can be in meter. So therefore you can say that the unit of work is equal to Newton and meter. So this is the work done unit. Same way, instead of using this, there is one more unit which is known as joule. What is that unit? You can use Newton meter or you can use joule. Why it is joule? Because the person who discovered the work and energy formulas, he said that let's give a common formula, a common unit as joule. Okay, so that's the basic here. So now let's come to the problematic parts, which is the most fun part here. So let's see how to do the problems. So first question is, calculate the amount of work done when force of 30 Newton displaces a body through 25 meter in its own direction. That means if the body is moving in right, it will just keep on moving at right. So let me write what is given. So whenever you are writing, children, write given, then comma. What is given, children? Given is force. What is the force? Force is 30 Newton, right? Then displaces a body through 25 meters. So here displacement, which is D I S P L A C E M E N T, can be written as 25 meter, right? Now you need to find what is the formula. So what's the formula? I told you the formula earlier, right? You can write work done is equal to force into displacement. So what is the force? Force is 30 Newton. Multiply by the displacement, which is 25 meter, and when you are doing the multiplication, you will get the answer as, let me write it here, W, which is work done, is equal to 750 Newton meter, or you can write it as joule. Okay? Yes, so this is the way how you should write a problem. Now let's come to the second problem. So the second problem is, let's see the question. A boy does a work of 1000 joule. So here what's given? Here you can write given. Here work is given. So work is equal to 1000 joule and is dragging a sack of rice through a distance of 20 meter. So here distance is given, that is displacement, and displacement is 20 meter. Now according to the formula, first you always write what is the formula. So what is the formula? Formula is W work done is equal to force into displacement. So you need to find what is the magnitude of force applied. So you need to find what is F. So what you can do is, here this is in multiply. So when I keep it aside to the equal to or the other side of the equal, this multiply will become here divide. So therefore you can write the formula as force is equal to W divided by the displacement. Now both the values you are having, right? So let's put in the formula. So you can write the, therefore force is equal to work done, which is 1000 divided by the displacement, which is 20, and therefore you just cancel out the 0 0. From 2 table you can write 2 ones are, 2 50s are. So the answer will come here as 50. What unit? Force what unit? Yes, force unit is Newton. So therefore finally you can write that force is equal to 15 newtons. Okay children? So this is the way how you should do the problems. So students, this lesson is only about work and energy. So children, we have discussed about two types of problem with the same formula. So just keep in your mind the formula and the explanation which I gave you. Until we meet next time again with a better video. Till then, bye bye.